Hello everyone. Today we will be going to solve this daily LeetCode problem. Make string a subsequence using cyclic increment. So let me quickly explain you the problem first. So in this problem we have given two strings str1 and str2, and we can choose a set of index from this str1 and we can increment them cyclically. It means we can convert a into b into c, and if we reach to the last character z, then it can be converted into a. So it's in a cyclic order, like a converted into b converted into c, and up till y converted into z, and z again converted into a, right? So what we need to do, we need to return true if it is possible to make this string 2 a subsequence of string 1 by performing at most one operation. It means we need to choose some set of indexes from this string 1 and apply the operation to kind of increment to the next character, and need to compare whether we are having the subsequence of string 2 in string 1 or not, and if it is there then we need to return true, otherwise need to return false. So let's see some examples. So over here we are having this string 2 as ad. So if we see, you need to find whether there is a subsequence of this string 1 or not. We can compare if is a is there or not. Yes, e is there, a is there. Is d is there or not? So d is not there. So what we can do is c can be converted, p can be converted only into c. So will it satisfy our condition? No. Will c can be converted into d? Yes. So a and d is a, it means a, b and d is a subsequence of this ad, right? Like ad is a subsequence of this string, so we can return true from here. Over here we are having zc, and here we are having ad, so we need to check whether we can get this ad from this string 1 or not. So this z can be converted into a, and this c can be converted into d. So by this we can say we are having this ad in this string 1 as well. So let's say if at any in any given case, let's say if string 2 is having size of 5 and string 1 is having size of 4. So in that case we are not able to find all the characters that are present in string 2 and string 1. So over here we need to return false, because no way we can get the subsequence. Let's see in this case. So over here we are having one character d. So d can be created from this ab. So a can be almost converted into b, b can be converted into c. So this bc will not able to get this character d, so will return false on this case, right? So how we can solve this problem? So one is brute force, right? So ultimately brute force will not work. Let me show you that as well. So what we can do, let's say if we are having 5 indexes, 1 2 3 4, right? 0 1 2 3 4, these 5 indexes we are having in string 1. So we decided to increment some of them, right? So how many cases we can create, how many set we can create from this 5? So it will be 2 to the power 5 minus 1. I think it is almost, this is 16 32 31 cases. So what are those cases? So first we are decided to not choose any one of them. Then we have decided to choose this for index 4 to be converted into some other character, next character, and this will be 0 0 0 1 0. This, now we have chosen this one. So for every point we have two choices, not two choices, we can say we are having 0 and 1, right? We are having two choices whether we can select this one or not this one. So at every point we are having two choices. So 2 into 2 into 2 into 2 is, it is 2 to the power 5, right? And at one point we are having no choice, we are not selecting any one of them. So in total we are having for let's say 5 indexes, we are having 2 to the power 5. So let's say if we are having n indexes, then it will be 2 to the power n cases that need to be considered. It means we are having this many sets, whether we can increment it, and then we need to compare it as well with the our string 2, okay, whether this is a subsequence or not. So this will be exponential time complexity, like 2 to the power n into m, right? Because we need to compare it as well with the string. So this will not work because our constraints are up till 10 raised to power 5. So how we can optimize this problem? So for optimizing it, what we can do, we can choose a 2-pointer approach. So let's take this example. So what we will do, we will iterate from this string 1, right, from left to right, and we will take the first character of string 2, and we'll try to find the equivalent character in the string 1, and we need to find it as leftmost as possible, as left as possible, because if we find as left as possible, then we are having more chances of finding this remaining character remaining character of string b into this remaining character of string 1, because we are having more number of characters, right? So it will ensure us ki if we are finding any character equivalent character for c in the leftmost part, we will be going to find these many characters as well with a more probability, right? So let's start with the iteration. Let's take this example. Yeah, so let's say if we are at this index 0, so will a can be converted into c? No, a can only be converted into b, so we will move forward. Now can b can be converted into c? Yes, b can be converted into c by choosing this as in our set. So we have chosen this as this need to be incremented, so this can be converted into c. So this is satisfied, this is satisfied. So what we can do, we can move our iterator of string 2 to the next character. Now can c will be converted into c? So we don't need to convert c into c, because c is already equivalent to c, so we don't need to increment this. So we can move the iterator of string 2 to the forward one. Now we are having d over here. So can d can be converted into c? No, d cannot be converted into c. So, and as all the characters of this string 1 is finished and we are still left with one character, so what we can do, we can return false in this case. So what we can do, we can keep on iterating in this, and we'll try to find the equivalent character of string 2, and once we find it, we can increment the iterator of string 2, and if we have handled all the character of string 2, then if we reach to the end of the string 2, we can return true in that case. And the time complexity for this problem is we are iterating in this string 1 as once. So let's say the size of uh, number of characters in string 1 is n, and the number of character in string 2 is m. So the time complexity is m plus n, because we are just iterating through all the characters of string 1 once and all the character of string 2 once, so it's m plus n. So as we are given string 1 is up to 10 raised to power 5, and string 2 can also be 10 raised to power 5, so it's 2 into 10 raised to power 5, so it will handle our case. So let me quickly code it out. Yeah, so what we can do, we can convert this into a, this into b, and I can take size of a is a dot size. So so I have selected n and m as the size of a and b, and if in any given case if b is greater than a, we can directly return false in that case, because we need to have more characters in a more or equal characters in a than b in order to having the subsequence, right? Now we can choose one iterator, and initially it is 0, so this iterator is for this string b, and we can iterate through all the characters of a, and we keep on checking if a of I is equal to b of iterator, or by incrementing the character of a, it should be matched with our b character, right? So iterator of this, so we can convert it in some integer so that we can take the modulus as well, because while incrementing it may having the more value. So let's say if we are at z, it means the value is 25, and if we increment it goes to 26, so it again need to get to the 0. So if this equal to a of I minus a plus 1, we are incrementing, and we need to take the modulus of 26, and if any one of these satisfied, we can increment the count of we can increment the iterator of string b. And after that, if at any position if we find iterator of b reach to the last index, we can more than the last index, or reach all the indexes, we can return true from here, else we can return false. So let me test it out. Yeah, so all the sample test cases passed. Yeah, so I already explained you the time complexity. Let me quickly explain you the space complexity as well for this case. Yeah, so as I said, the time complexity is m plus n, because we are iterating through all the character of a ones and all the character of b ones by taking this iterator. And the space complexity, we are not using any extra space over here, so it is constant, so O of 1. Thank you for watching.